Hello everyone, this is Mr. Griesel, and we're going to be looking at worksheet 4B. Once again, this is in Unit 4. This is all about trig identities, and this is probably the hardest worksheet we've had all year. It's unfortunate that I have to teach it to you this way. So hopefully, through these examples, you're able to understand it pretty well. Looking at what we did last time, we filled out the trig identity sheet, and that, once again, that sheet is in the drive. It's on Schoology. I put it all filled in, so yours is blank. So when you do it, or when you pull it up, the one I put up is all filled out. So you're just gonna, copy down the formulas, or the identities rather, and those are what we're going to be using for this entire chapter. So we're going to be using them a lot today. We're going to be relying mainly on the first half of that sheet, just because the other ones don't come up till later worksheets. So let's look at worksheet B in Unit 4. All right, so first of all, we're going to look at example 1. If you see, there's two different problems there. There's one I'm going to show you how to do all the steps for, and then the other one's intended as like you should try it and see if you understand how to do it. So if you want to watch me do the first one and then like pause the video for the second one and try it and see if you can figure it out, I think that would be the best way to do it, because then you'll really understand if you got it, and kind of working through it, making mistakes is a good thing a lot of times. So let's look at example 1. All right, so on example 1, we have 1 plus secant of x times sine of x times tangent of x equals secant of x. So what they ask us to do on this one is verify that the following equation is an identity. So basically, all you're trying to do on these is make one side of the equal sign look exactly like the other side. Now, a lot of times it's really obvious which side you're going to tackle. On this one, we're going to tackle the left side for sure, because there's a lot more to do on that side. If you look at the right side, it's just secant squared of x. So, I mean, you could turn that into 1 over cosine squared of x, but there's really not much more to do after that. So we're going to deal with the left side, and we're going to attempt to make that look like the right side, and we'll go from there. So first step we do is we just look on our trig identity sheet, and we exchange the secant of x for 1 over cosine of x, and then the tangent for sine of x over cosine of x. All we're doing is switching those out. Nothing really amazing happened there, but that's how we got. Then I'm going to take the sine of x and put it over 1, so all of those are fractions. I'm going to multiply the tops and the bottoms all together, and the right side's not going to change at all, and that 1 out front's not going to change at all for now. Okay, if I do that, I'm going to get sine squared of x up top, cosine of squared of x on bottom. Now, if you look at your trig identity sheets, we're going to find that sine squared of x over cosine squared of x, ignoring the squares, is going to make that tangent of x. So we're going to call that 1 plus tangent squared of x. And that's what we get right here. So 1 plus tangent squared of x equals secant squared of x. If you look at your Pythagorean identities, the middle one says tangent squared of x plus 1 equals secant squared of x. Well, that's exactly what we have on this last step. So I'm going to exchange the left side for secant squared of x. And so at the end, you get secant squared of x equals secant squared of x. The left side and the right side match. I didn't have to do a thing to the right side, so we kind of just left it alone the whole time. And that's what we got. So at the end, when you've proven, that something's an identity, I like to put a big old check mark and write QED. QED is a Latin term for quo equum demonstrata, I think. And basically that all that means is look how easily I've demonstrated this. So it's kind of telling whoever's looking at it that you're done, basically, and it's done well. So there we go. All right, so now if you want to pause the video here and try this problem on your own, it's super duper similar to what we did on example 1, but it's a little different. So Like I said, if you want to pause it, go ahead and pause it now, and then I'll start explaining it here in a second. Okay, I hope you tried it on your own. Let's see how you did. So first thing I did is on the left side, I exchanged secant of x, cosecant of x, and tangent of x for all their counterparts off of the trig identity sheet. The sine of x and sine of x cancel out because they're on bottom and top. So we get 1 over cosine squared of x. 1 over cosine squared of x is the exact same thing as secant squared of x, so I switched that out. And then using that exact same formula that we used before, the Pythagorean identity, where tangent of x, or tangent squared of x, plus secant squared of x equals 1, I think it is, we're able to get this. So you do have to manipulate it a little bit to make it look exactly like 1 minus sine or secant squared of x, but you would end up getting negative tangent squared of x. So negative tangent squared of x equals negative tangent squared of x. You put a big fat check mark and you say QED for quo equum demonstrata. All right, so let's look at example 2. So for example 2, what do we have? So all we're going to do is, I think it says find the product. So all we're going to do is multiply these. Now this one isn't super complex. We're going to do a substitution on the other one, but for this one we don't really have to because it's pretty easy. So this is just straight up foiling. We're going to do first, so you get 1 minus tangent of x. That's pretty quick and easy. Then you do the inner and last for FOIL. So tangent plus tangent of x minus, and then tangent times tangent is tangent squared. Positive times a negative is negative, so it's negative tangent squared of x. So hopefully that's not too crazy for you. The middle two terms cancel out. We have negative tangent of x, positive tangent of x. We get rid of those. I'm going to flip-flop the order because I want it in standard form. So negative tangent squared of x goes out front. That 1 is positive, so we're going to bring it to the end and just put plus 1. This whole thing is done, so we really don't have to do anything else, and we just call it a day. Now, if you want to pause the video here, I will warn you that I did do a bit of a trick, but you can do it exactly the way you normally would. So if you want to try this one, go ahead and give it a shot. And when you're all done, unpause it and I'll tell you the answer. Okay, good work. Let's see if you got it right. So at the beginning of this, I said there was going to be a trick to this one. The trick to this one is I'm going to exchange out the sign of A for just any letter in the world. I'm going to pick X because it's easy. And the reason we're kind of doing that is because it's going to get pretty messy. And if you don't do that, it's really easy to make a mistake. So let me show you what happens, okay? So instead of having 2 sine of A plus 1 and then all that being squared, I'm going to call it 2x plus 1 and then squared. So that looks a lot more familiar. That's an Algebra 1 problem. So we're going to write 2x plus 1 times 2x plus 1. We're going to do some regular old FOIL. And I don't know why I put parentheses around that. You don't really need that. But you got 4x squared plus 2x plus 2x plus 1. The two x's are going to combine, and you're going to get that. Now, at the end, since you switched out sine of A for x, we have to undo that. So all the places you see x, we're going to put sine of A, and then we'll be all done. So, yeah, x equaled sine of A. So we're going to say 4 times sine squared of A plus 4 sine of A plus 1, and this is all done. We don't have to do anything else. So these ones are pretty easy. You're just finding the product. There's no tricky business to it. Okay. All right, example 3. What did they say to do for this one? I don't remember. Oh, okay. So we got to factor this one, okay? So we have secant squared of x minus tangent squared of x. So just like on the last problem, I'm going to do some substitution because I don't want to be dealing with secants and tangents, and especially if I'm doing factoring, because factoring is kind of a messy business on its own. So secant squared of x, I'm going to call that A. Tangent squared, or tangent of x, I'm going to call that B. So both of those are being squared, so when I plug in the A and the B, they're going to still be squared. And I'll show you what I mean. So we're going to have A squared minus B squared. And that's after I exchange those secants and those tangents for the different letters. So from here, you might know the trick, and if you know the trick, by all means use it. But I'm showing all my steps on this. So for this one, we don't have a middle term, so we're going to put our x over here to the left or whatever. I'm going to multiply the first term times the last term, so a squared times negative b squared gives me negative a squared, b squared. And then on the bottom, I don't have a middle term, so I have to put a 0 there. And to solve this diamond problem, or whatever you guys call it, I got to figure out what multiplies to make the top that adds up to make the bottom. So if you run through those, this is kind of a hard one, to be fair. What you end up getting is negative AB times AB, because if you add those up, they'll add to 0. If you multiply them, you'll get negative a squared times b squared. Okay, so if I have that, what I'm going to do is rewrite that, and the negative AB and AB get stuck in the middle. The beginning and end don't change at all. And then we, if we're factoring by grouping, we toss some parentheses in there. The first set of parentheses, they both have an A. Second set of parentheses both have a B, so we factor that out. You end up getting this, and then that turns into this. So you get A plus B times A minus B. So if at the beginning you recognized, oh, these are going to turn into conjugates, that's exactly what happened. So these turned into conjugates. Now, at the very beginning of the problem, we said secant of x equaled A, tangent of x equals B. So we got to replace all those. So instead of calling it A plus B times A minus B, we're going to toss all those trig identities in there, so you get this big mess, but that's your answer. Okay, so once again, we're utilizing substitution just to make our lives easier, because if you were using secants and tangents and all that mess, it would have been really, really difficult to keep everything organized. So you can use substitution if you want, but like I said, if you do it, it just makes your life a lot easier. Okay, so if you want to, go ahead and try this problem on your own. Pause the video, and then when you feel like you got a decent answer, unpause it, and I'll go over the answer for you. Okay, so let's see how you did. So we have sine squared of beta plus sine of beta minus 2. Now, at the beginning of this problem, I'm going to do some substitution. I'm going to call sine of beta some letter. In this case, I called it x. So I'm going to stick the x in for sine of beta, so we get an x squared at the beginning plus an x minus 2. So this is a lot easier and a lot simpler to follow, just because, this looks familiar to us. So, if you don't know how to factor this, I'm going to do it the long way. So x squared times negative 2 is negative 2x squared. X goes on bottom, and we got to think of two things to multiply to make a negative 2 that add up to a positive 1. Well, that's going to be 2 and negative 1. So those replace that x in the middle, and that's what we get. Toss some parentheses around all that. The first set of parentheses, you're going to factor out an x. Second set of parentheses, we're going to factor out a negative 1. The two parentheses match, so we did it right. So we're going to call this x minus 1 times x plus 2. And that is not our final answer, because we exchanged x for something at the beginning. So we said sine of beta equaled x, so we got to switch those out. So we're going to get sine of beta minus 1 times sine of beta plus 2. Okay? Hopefully, that wasn't too bad. Okay? All right, so example 4. Example 4 and example 5 are really tough. You're using just a ton of stuff on these off of the trig identity sheet, and then just some algebra skills that you have to be good at. So if these problems are really tough, I very much encourage you to go on YouTube, and you can look up Khan Academy videos on trig identities, improving things are identities. But let me walk you through these, and hopefully this is enough for you, okay? At the beginning of this problem, it says, prove this is an identity. Now, it's really unclear at the beginning of this which side to tackle. We can't really do much on the left. We can't really do much on the right. So since we have fraction equals fraction, I think the best thing to do here is cross multiply and then just simplify everything you get. So I did those two times each other at the beginning, and those are conjugates of each other, so those are going to FOIL out really nicely. And then I did those two times each other, and it's just going to be cosine squared of A. So that side's pretty well sorted. The right side we aren't really going to do much with that beyond that. So the left side is really where we're going to focus a majority of our attention. Okay, so on the left side, we get 1 minus sine squared of a, and that's because the middle term cancels off because they're conjugates of each other, like we said. Then from here, this is a trig identity you're going to use a lot. And I'm going to use it probably, I think, on the next 3 problems. So let me show you where I get this. This comes from the Pythagorean theorems, Pythagorean identities. And it starts off life as sine squared of x plus cosine squared of x equals 1. Well, that's not what we have in this problem. We have 1 minus sine squared of x. So what we're going to do is we're going to kind of manipulate this to make it look how we want. So this is what we're starting with. I'm going to subtract sine squared of a from both sides. So you're going to get cosine squared of a equals 1 minus sine squared of a. The a's and x's, don't worry about any of that. It doesn't really matter what you're talking about on that. But the right side looks a lot like what we have on the left side of our equation. So if we come back here, 1 minus sine squared of a turns into cosine squared of a. So we end up getting cosine squared of a equals cosine squared of a. Those are the exact same things. So we put a check mark and write QED. That's all done. Okay. That Pythagorean identity, this one that we just showed, we're going to use this a ton. So if you remember this one, it's going to save you a lot of time, okay, instead of having to manipulate this every single time, okay? All right, so if you want to give this a shot, go ahead and pause the video, try this one. I would definitely tackle the left side and try and make it look like the right side. But yeah, give it a shot. Go ahead and pause and then come back when you're done. Okay, so let's see how you did. Now, the first thing I'm going to do on this is I'm going to exchange out that cosecant for 1 over sine of x. And then sine of x, I'm just going to turn into a fraction so that I can turn those into one fraction total. Now, I can't combine the 2 top fractions because the bottoms don't match, so I have to multiply the one on the right by sine of x over sine of x. You end up getting this. Now the bottoms match, so we're going to be able to combine those 2 top fractions into this. This is kind of messy, but it's what we have so far. On the bottom, I'm going to turn that into a fraction, so we have fraction divided by fraction, and we can do keep, change, flip. So keep, change, flip this, and we're going to end up getting it to look like this. Now we multiply the tops, multiply the bottoms, you're going to end up with this. Now that 1 minus sine squared of x, that should look familiar. We just talked about that on the last problem. And so what we're going to do is we're going to go back to that formula. We said 1 minus sine squared of x was the same thing as cosine squared of x. So we're using that same little trick again, okay? So, and that once again, that all comes from the Pythagorean identities. So that top gets changed out for cosine squared of x. Now, at the beginning of this problem, the right side was cotangent squared of x. And if you look at cotangent of a from our identity sheet, that's the same thing as cosine over sine. So cosine squared of x over sine squared of x is really the same thing as cotangent squared of x. So the left side of our equation is going to turn into cotangent of x. The right side of our equation is cotangent of x. Those 2 are the same thing. So put a big check mark and write QED. Okay, example 5. This one, at the beginning of this problem, when I look at this, the left side's kind of nice and neat. It's all bundled up into one little thing. So 2 tangent squared of x, we're not going to do much with that. The right side, there's a lot of work there to do, and it's kind of sophisticated algebra, but we're going to deal with that side first, okay? Now, I have 2 fractions they're subtracting. I can't do anything until the bottoms match. Well, the bottoms, one of them's minus, the other one's plus, so we got to multiply both of them by the opposites of them. So this is going to be a bit of a mess, but it's going to end up looking like this when you multiply it all out. Now, the bottoms are conjugates, so that doesn't really get too messy. We have cosecant squared of x minus 1 on both of them. The tops, they don't really turn into much. But once we get it to this point, bottoms match, so we're able to subtract the tops. So if I subtract, well, on this step, I'm showing that the bottom's still the same. Okay. Up top, on the top of that fraction, the cosecant of x minus the cosecant of x, those go away. And then I have 1 minus minus 1. Minus minus turns into plus, so 1 plus 1 is 2. So I get 2 on top, and the bottom's still going to be the same. So that kind of got a lot neater. On bottom, we see that we have cosecant squared of x minus 1. Well, I'm going to switch out the cosecant for 1 over sine of x, and it's squared, so it has to be 1 over sine squared of x. That 1 on the right side, I can't just leave that as 1 because I need to turn those into one fraction. So I can make that whatever I want as long as the top and bottom are the same. So I called it sine squared of x over sine squared of x. And the reason I chose that is because now the bottoms are the same, and I can turn those bottom two fractions, I can subtract them now because the bottoms match. So if you do that, you're going to get this. And so we have 1 minus sine squared of x over sine squared of x. And the 2's up top, we're kind of ignoring that for the moment. Now that 1 minus sine squared of x, that should look familiar. It's kind of a theme on the last three problems. So 1 over sine squared of x, if we look back at our Pythagorean identity that we talked about, that's going to turn into cosine squared of x. And so we just switch that out. So we get that. And now, and that once again, that comes from there. So now I have that 2 up top. I'm going to turn that into a fraction, so I just call it 2 over 1. Put a dot for multiplication, and I'm going to flip that bottom fraction. So I'm doing keep, change, flip to get this. Okay? So multiply the tops. We get that. 1 times cosine squared of x is just cosine squared of x. And so I have this. And now sine over cosine, if you look at your identity sheet, is the same thing as tangent. Now, if both of them are squared, we can call it just tangent squared of x. So this is really going to turn into 2 tangent squared of x. Now, at the very beginning of the problem, the left side of this said 2 tangent squared of x. So 2 tangent squared of x equals 2 tangent squared of x. So we put a big check mark and we say QED, because we proved the right side is the same as the left side. Okay. Now, this is the last problem. So go ahead and give it a pause and try this. This is one of the toughest problems we've ever had. So if you don't get it, don't feel too bad, because this is a really tough problem. Okay. So give it a pause, give it a try, and see if you can't get this one on your own. Okay. All right. So welcome back. We are going to try this problem. Now, both sides of this are kind of messy, so we're going to tackle them both. I'm going to end up doing some cross multiplication, but if you notice, the first feature of this is there's negatives inside the parentheses. That doesn't happen too often. That happened on worksheet A, if you go back to that. So what we have to do is we have to find our odd identities on here. And both of those are going to be in this little box right here. So sine of negative x, the negative kind of comes out front. Cosecant, the negative when it's inside the parentheses kind of comes out front. So that's going to happen twice for us. So if I look at this, the cosecant on the bottom, that negative comes out front. So instead of being 1 minus cosecant, now it's going to be 1 plus cosecant, and now the t is positive. Up top on the right side, that negative in front of the t pops out, and so that plus now becomes a minus, so we have 1 minus sine of t. So that all comes from the odd identities, and if you didn't recognize that, then you're not going to get anything else right. So if you got that, that's great. So let's go from here. So now, on the left side, we also have that same thing that keeps coming up. We have 1 minus sine squared of, and in this case it's t. Well, if we recognize that again, that 1 minus sine squared of whatever equals cosine squared of that, we're going to change that out as well. So on the top of that, left side fraction, instead of calling it 1 minus sine squared of t, I'm going to just call it cosine squared of t. And once again, that all comes from the Pythagorean theorem identity. Okay, that's been in the last 4 problems. So like I said, it's going to be really beneficial if you can recognize that without having to manipulate it every time. All right, so from here, I got a bit overzealous on this step, and I circled what I'm going to do for cross multiplication. But left side fraction is good, right side fraction is good, so we're all set up to cross multiply. So on the left side, we're going to get cosine squared of t, cosecant of t equals, and then those two times each other. That right side is going to turn into a bit of a mess, but we'll deal with it, okay? On the left side of this, I call cosine squared of t, I put it over 1. And cosecant, if you go back to your identity sheet, is the same thing as 1 over sine of t. So this is going to turn into 1 fraction when I multiply the tops and bottoms, but this side is sorted for now. The right side, like I said, this turns into a mess. We FOIL this out. 1 times 1 is 1. 1 times negative sine of t is just negative sine of t. Cosecant of t times 1 is cosecant of t, and it's positive, so we put plus cosecant of t. And then cosecant of t times negative sine of t is those two multiplied with the negative out front. Not fun over here at all. This side's going to be a bit of a annoying, but we'll deal with it. Okay, left side, like I said, multiply tops, multiply the bottoms. It turns into this nice, neat little fraction. We leave this alone. Okay, right side, we are going to exchange, we're going to basically turn everything into a fraction here so that we can get it all into one fraction at the end. So the 1 out front, I didn't know what to turn that into, so I just brought it down. The sine of t, or negative sine of t, I'm going to call that negative sine of t over 1. The cosecant, I'm going to call that 1 over sine of t. The cosecant is 1 over sine of t, and then the sine of t is just sine of t over 1. So basically, I just made everything a fraction, and the reason I didn't do it to the 1 yet is because I don't know what's going to be beneficial for that. So we're going to wait to see what looks good for us on that one. Okay, so these ones, I didn't change anything yet. So, I don't know, I just dropped those down. Okay, these ones, the sine of t, that's sine of t. The sine of t and on top and bottom are going to cancel off. So we're going to get 1 divided by 1, and that all turns into a 1. So at the very end, I spilt my t right there. We're going to have just a minus 1. So that whole thing right there turns into a 1. So that's good to go. So this is what we're left with on this side. Okay, the 1 at the beginning, the 1 and the minus 1 are going to cancel each other off. So 1 minus 1, those two go away. Okay, so I'm left with sine of t over 1 plus sine of t. Okay, I can't do anything to these because the bottoms don't match. So what I'm going to do is I'm going to make the left side fraction sine of t over 1. I'm going to multiply that one by sine of t over sine of t. Then the bottoms will match, and that's what I did here. So then we're going to get sine squared of t over sine of t plus 1 over sine of t. Now the bottoms match, so we're going to be able to add the tops and keep the bottom the same. So if we do that, we get sine squared of t plus 1 divided by sine of t. Okay, so that's good to go. Now, I noticed a problem here when I was doing this problem. I saw sine squared of t plus 1. That looks a lot like that Pythagorean identity, but it's not quite right because there's a minus sign missing. Okay, the top of it is supposed to turn into cosine squared of t using that Pythagorean identity, but it's not quite there because it's sine squared of t plus 1. So what I figured out is I made a mistake. And the mistake is, if you look at the very top step here, that minus sign in front of the sine of t plus 1, I didn't bring it down. So this minus sign right here, I didn't include it on the next step. So I had to go back and drop down the negative sign, and then drop down the negative sign again, and then drop down the negative sign again. So I get negative sine squared of t plus 1. Now this looks a lot better. It's in the reverse order that we had it on the previous problem. So we had 1 minus sine squared of t But this is negative sine squared of t plus 1, so it's just flip-flopped. So it's the same thing as our identity that we've been using. So I'm going to exchange the top of this for cosine squared of t, and you're going to get this, and that matches exactly what we have on the left side. So the left side matches the right side. Put a big check mark, write QED. We're all done. Okay, so very, very, very difficult problem, that last one, but that's where we need to get to. So if you need a lot of practice on that, then give yourself a lot of practice on that. As you can tell, these problems are not nice and neat, and you can't typically fit them on the piece of paper I gave you. So if you need to use an extra sheet of paper, this is all the paper I used. I'm using a Sharpie and writing really big, but some of you, this is how you write. So if you need a lot of paper, this would be the chapter for it. Okay. So the rest of the worksheet, there's 14 problems, and they're very, very similar to what I just did. So use the examples that I gave to help you with this. If you have any questions at all and you need to email me, feel free. And I'll get back to you with questions answered. If you need to send me like a picture from your phone or whatever, like, hey, I got stuck here, what did I do wrong or whatever, feel free. Like I said, you guys can talk to each other. I don't care about that at all. If you need to look up help on YouTube, or I don't even know if Photomath will do these. I kind of doubt it because this is pretty sophisticated stuff. But whatever help you need to get, feel free. But if, like I said, if all else fails, give me an email. Okay. Once again, we're using these trig identities a lot. So if you haven't written these down, write them down. We really didn't get that far on this sheet yet. So we're still in chapter 6.1. So that top like half a sheet on the left side, that's all we've really used so far. On later worksheets, we're going to use the sum and difference identities. The cofunction identities are a beast. The 6.4 double angle and half angle, we'll use those. Those aren't too bad. And then the product to sum and sum to product, those really aren't too bad. It's kind of just like a recipe. You plug stuff in and you get out what you're supposed to get out. So what we did today is probably some of the most difficult stuff. But like I said, I'll put up a couple more videos. I put up one for 4A. This is 4B. I'll put up one for C, D, and E. And then that will be the whole chapter. I'm not sure what CCA is going to do in terms of testing or what they expect from you, or if we're going to get college credit. So when I hear more about that, I'll let you know. Today is Friday for me. I don't know what day you guys are watching this. Today's Friday the 27th of March. So yeah, that's what I know as of that date. Okay. So good luck on that. If you guys have any questions, like I said, please feel free to email me, and I'll be happy to answer those. Okay? Have a wonderful day. Wash your hands. Stay outside. Don't get crazy. Or no, stay inside. Stay inside. Okay? Have a good day.